Shh. This video now starts with me shushing you. It's like a summary of the year in a video moment. Can you stop? Oh, we're going right. The function is defined by e to the 2x minus 3e to the minus 2x. Show that f dash x is greater than 0 for all x. What's f dash x?
Differentiate.
The derivative dy by dx. Okay. So. All this means is it wants us to differentiate. So we differentiate it, and we get, what do we get if we differentiate it to 2x?
2e to 2x.
What do we differentiate if we get minus 3e to the minus 2x?
Plus 6. Plus 6e to the minus 2x.
Okay. Now, the question says, show that it is greater than 0 for all x. Well, what do we know? How can we go about doing this then? It just is.
Put a positive value in, a negative value in.
Just trial and error it, Leo.
Yeah, put all the values in. Everything that x could be, put in.
Well, there's no way for it to be negative.
Can't you just say? This is it. Show that it's positive.
We want to break.
Yeah, just small.
X. Show that it's always increasing. I mean,
always a
what we
positive
could
value.
say, we know, don't we, that e to the 2x
Or e to the x is always positive.
is always positive, is it?
Yeah.
No.
Yeah.
Yeah.
Yes, because you've always got a dominant positive. It's like 2x or something is always going to be more positive than minus 2x is going to be more positive.
E? Well, it doesn't matter what the x value is because e to the x is always
E
going to be positive.
E
So it
to
doesn't
the
matter.
minus 100, actually no, it's like 10. It's just small, and they've times it like 2.
It's because it's that graph, innit? So it never is negative.
Yeah, it's just an E graph.
E to the x graph.
It's that simple. Oh my god, absolutely.
Yeah, draw the graph.
They'll love that one.
Yeah, they'd believe
Pull it out of the graph.
So we know that e to the kx, no matter what k is, e to the x, e to the something x, is always positive because we know what e to the x graph looks like. It looks like that. If k is positive, if k is negative, it's the other way around, but it's always positive. So therefore, that must be greater than 0 for all x, because we're adding together two positive graphs, two positive functions.
What does the mark scheme say?
The mark scheme wants us to say e to the 2x is greater than 0 and e to the minus 2x is greater than 0, or to make a more general comment about exponential functions.
Cool.
That's what it. Part B. Show that the set of values for which the second derivative is greater than 0 is the same as the set of values for which f of x is greater than 0, and state what this set of values is. Okay? Well, I think the first step on this is we're going to have to find the second derivative, which would be 4e to the 2x minus 12e to the minus 2x. Okay. Now, we're supposed to be showing the similarities between this and the original function. Well, hang on, before we do anything else, look what we can notice here. There's a common factor of 4 in that expression we just written. If we take out that common factor of 4, it looks like that. And so in fact what we're spotting straight away is that f double dashed x is just 4 times f of x. That's it.
Well, you got to show what the set of values is.
How is
You do.
You got to, yeah, and show where the
So,
yeah.
How do you get 5 marks for about 2 lines?
You've got to find the set of values.
And we've got to find the set of values. Yeah. So that's shown that the set of values would be the same. Stay with this set of values. So we want to find when is f of x bigger than 0. That means that e to the 2x minus 3 e to the minus 2x is bigger than 0. We've got to solve that.
Dave, you don't have to justify this statement above to say that it's only affecting the y-axis, the stretch. So hence the domain would be the same. Or you're okay with that?
I think that's not. We're not saying that as a stretch. You're right. It's a stretch, but we're just saying if that has a particular set of values for which it's positive, and you times that by 4, it's the same set of values. Because if you times 0 by 4, you get the same. You still get 0.
Okay.
I think that's sufficient to make that statement. What we're going to do with this, it's kind of recalling stuff from some time ago, isn't it?
It's fine. I don't know.
How would we solve this equation?
Logs?
We take the three across from the
I
side.
don't think we would just yet. No? This is interesting, because this is, if you spot it, this is now really easy to deal with.
Oh, can you? Oh, no.
But if you don't, you can get tied in all sorts of natural loggy sort of knots and a little bit.
Can you bring down the minus from the 3 to the minus 2x?
That's the thing.
And
This
then
is-
factorise out e to the 2x?
That's it. If we do that, we can now multiply both sides by e to the 2x.
Oh, yeah.
So like that.
What a guy.
And now it's looking pretty nice, isn't it? Can we concentrate with me, please? And so we're going to say that e to the 4x is bigger than 3. And we would now take natural logs. Because now we're going to say that 4x is greater than the natural log 3. Is that right? Let's just be careful that we want to. Yeah, we don't divide by anything nasty there. So x is greater than a quarter, and then 3. And we're done. Yeah.
You know, sometimes when you do stuff, you have to change the sign around. So
Yeah.
what makes you have to change the sign around?
We're changing the sign around if we divide it by something that's negative, or
So-
multiply by something that's negative.
Is that it?
And that's it. And we haven't in that case.
Can you get e to the 4x?
Okay, we're on to
You times, and if you times something e,
Part
start
two.
with powers.
Okay.
the function is defined for all real values of x by that. So hang on, was there a link between what we just done? We just did e to the 2x minus 3 e to the minus 2x. Now we've got e to the 2x plus k e to the minus 2x. So it's the same as what we're dealing with, but instead of minus 3, it's got k in there. Where k is a constant greater than 1. The graph is shown above. Find the range of giving your answer in simplified form. Remember, the domain is the set of inputs, and so the range, what this is saying, is find this set of values, find the set of y values, the outputs that you get from this function.
I hope we don't miss questions, maybe.
Now, to do this, we need to know what the minimum point on this graph is, don't we? That's basically all we need to work out. So let's see what we can do with this. The minimum point then, we're going to do g dash x. And do that. That minimum point occurs when g dash x is 0. then. And we've just solved an equation like this, so we know where we're going with this. This is 2e to the 4x minus 2k is 0. So e to the 4x equals k. I've divided by 2 and taken the 2k over to the side at the same time. So natural logs 4x is lmk. Doesn't matter what colour you write that. Any ink is okay.
Definitely silence.
So we've got that. We've got, there you go. 1/4 lmk is our x value. And the range though, that's about the set of y values, isn't it? So what do we have to do with this x value? Put it back into the function to get the y values. So when x equals 1/4 lmk, g of x is e to the 2 times 1/4 lmk plus k times e to the minus 2 1/4 lmk. This it's a little bit mean because they're really testing you here that you can't just stab this into a calculator and get an answer. We actually have to think quite carefully through what's going on with this. Now I think we've got a half lmk, which is lmk e to the lmk to the half. Is that okay to go straight to writing that? And here we've got plus k, and here we've got minus a half, so we've got ln k to the minus a half. Oh, that was an e there. There we go. Just kind of have a moment to make sure that you can get from there to there. We've got 2 times a quarter, so it's half of lmk, and of course that can go up as a power of k, so it's lmk to the half. And here we've got minus a half, so it's lmk to the minus a half. Now, e to the ln x is x. E to the ln 5 is 5, because one is the inverse of the other. Are you happy with that? So e to the ln k to the half is k to the half. And here we've got k times e to the ln k to the minus a half. So k times k to the minus a half.
Okay.
And k times k to the minus a half is k to the half. That's, think about adding your powers. That's quite nice, going back to the first week of core 1. We've got k to the 1 times k to the minus half, that powers you get a half. We've got 2 root k. There, k to the half is k to the half. And so, finally, the range of g of x is greater than or equal to root k. Sorry, I'm going to put an x in there after all that.
I can see why we have to do so well on that.
Yeah. If you get it, you just get it straight away.
Do you want to do a farewell speech? Or?
Should I do a farewell speech?
Yeah.
Do the song again.
Yeah, do a song.
Yeah, do a song.
Song.
That was it, that was my farewell speech.
Teddy Tubby bye bye.